Hi everyone, my name is Peter. Welcome to this YouTube tutorial. In this section we are going to discuss the sulfonation of alcohols. So this is a continuation video from the previous one that I did. In the first objective I had halogenation. In this section I'm going to be dealing with sulfonation of alcohol. So like I said, that alcohol have an OH group, which is a very strong base or a very strong nucleophile. So it's very hard for that OH group to be displaced or to be substituted by other nucleophiles. So what we have to do is to make that OH group a beta leaving group. So sulfonation is one of the methods whereby we react the alcohol with a sulfonyl chloride compound, and then we form what we call a beta leaving group. So if I may use the general formula of alcohols, because all alcohols react in the same mechanism of action. So if this is my alkyl sulfonyl chloride reacting with the alcohol, so this OH group, the oxygen has a lone pair of electrons, so these lone pairs will attack the sulfur. So this will lead to the breaking off of this chloride bond, so giving us the RO H to this structure. So remember, oxygen has to be bonded to 2. It has 3 bonds, so it gets a positive charge. So this is when my my pyridine comes in. So this base attacks this hydrogen, then this bond breaks in favor of oxygen. So then our final product is going to be a sulfonated compound, which will look like this. So this is our final product. Now this product is a very good leaving group, whereby we can easily displace this oxygen from this alcohol by any other nucleophile. So therefore this is a general formula for all alcohols. So if I may use let me say this type of group, so this group can react with my sulfonated alcohol. So therefore this oxygen is going to attack this alkyl group, leading to breaking off of this bond. Then I'll have my final product as. So you see how I have replaced this sulfonyl group with a CH3O group. So now I have made the OH group a beta leaving group, and hence I've replaced it with another group that I can use when I'm making other compounds. Like for example, if I want to make an ether, this is how I make an ether. So this type of mechanism, these compounds, the ones we call alkali sulfonyl chloride, can be used to replace or to make the OH of the alcohol a beta leaving group. Hence the final product, the sulfonated product, acts as a storage. Like it's like a storage where something that we can use to elongate a chain or to incorporate in more functional groups in a given compound. For example, if I want to make an ether, this is how I make an ether. If I want to make something else, I can use, for example, if I want to make I can replace this with a S, with a nitrogen or an amine. So we can use these sulfonated alcohols to manufacture or to make or to synthesize other types of compounds. So let us do an example and we see how we can make other compounds from this sulfonated compound. So from the mechanism of action, we've seen that the final compound is always having, for example, if I may use sorry, if I may use so now if this is my sulfonated compound, so I can use this sulfonated compound to manufacture other compounds. How? By replacing this structure, I can replace it by any group that I want, so that I can elongate a chain or incorporate in a new functional group. For example, if I want to make an ether, so what I will do is I will bring in an ethoxy group. So this ethoxy group will attack this carbon, and this all bunch compound will break off. So therefore, if we draw this near here and see, I show you how it goes. So this oxygen will attack this carbon, and this whole bond will break off as one single entity. Then my final product will be CH3 to the O to the CH2 to the CH3. Then plus this whole compound as you see it there. So this is how we can make other functional group or incorporating more functional groups in a given alkylous sulfonyl compound. So this is an ether. So this can be called methoxy. Methoxy ethane. So this is a type of ether. So I can manipulate any functional group here so that it binds to this carbon to form something new. I can elongate this chain to make a longer ether, a shorter ether, or any other functional group that I want to incorporate in this structure. So therefore, that is all about sulfonation of alcohol. So thank you for watching. Catch you in the next video as we discuss other types of mechanisms that alcohols have. Bye for now.